more and more I talk about this topic, the more I realise that very few people really appreciate what the impact of our technology usage is in general. And I guess particularly with the financial services firms that I work with as well, the kind of blissful ignorance that many of us live in when it comes to the use of our tech. So many of us use devices every day. We have lots of technology, and we don't often stop to consider what's the real impact of this technology usage. And I'm going to talk a little bit in the talk about the wider impacts of some of that often don't get discussed. Because ultimately tech usage does have physical impact, it has real impact. That there are increasing amounts of land and power being used for data centers, but that's just one of 3 dimensions I'm going to talk to you about in terms of tech's impact. Because one of the other big ones is its physical, e-waste, its mining, its materials consumption, and other knock-on impacts there. And worse still, the tech space is filled with misleading greenwashing as well, which makes this a far, far harder topic for me to talk about, because many people just say, well, look, I'm seeing all these headlines. Like, tech isn't having any impact, tech's actually the answer. And it's not wrong that tech can help, but it's really not helpful when tech companies make massive, unsubstantiated claims that simply moving to cloud will improve your sustainability by 99%, which is what some of the major cloud providers are claiming. It's not helpful because it's simply not true. It's nuanced, right? It depends where your existing technology is. If it's running in a location where there is renewables energy on a regular basis, and you want to move to a data center that's run by a big hyperscale cloud provider, often those hyperscale cloud providers are in locations where there's a massive premium in demand for energy, and often it's not as renewable as they'll claim. And I'll come on to some of that. In fact, Vincent was touching on the fact that the technology companies' carbon reporting often isn't true. It's based on, for those of you who know the terminology, it's often based on market-based carbon measures rather than location-based, rather than the real true energy that's being drawn and used by the data centers. So there's a whole bunch of things here that make this topic quite hard to talk about. I've got a question, before I carry on, I've got a question for those of you in the room. Can you give a guess as to the percentage that a typical financial services firm's emissions relate to technology? Just, throw out some numbers. What do you think? 7%? 70, did you say? Yeah. Okay. 95, okay. Quite high, okay, all right. 35. Getting warm. Any advances on 35? Well, you weren't far off. It's actually between 36% and 45%. So there's a couple of links in this on this slide at the bottom here. One is a McKinsey report, but the other is actually the Dutch bank ABN AMRO did a full inventory of their entire carbon emissions and actually have broken it all down. So we're able to see that ABN AMRO's was close to the 45% or 40% mark. The different parts of the financial services world have higher footprints. A lot of it's based on how much data and technology do you have versus staff. And if you're a retail bank, you've probably got more physical real estate that's using energy and so on and so forth. But if you're more of a data-intensive financial services firm, more of a trading bank, then you often have more data centers than you do other facilities in the company. So before I go much further, I just wanted to give you a bit of a background as to who I am and who Scott Logic are. So Scott Logic is one of the proud sponsors of Finos. We've been involved in Finos for many, many years. In fact, some of you may have been at Colin's talk just now talking about AI. So it's quite funny. We've got Colin, my boss, our CTO, talking about AI, which is one of our challenging topics because it's the growth of AI is massive. Speak of the devil, Colin, and you come into the room. There you go. What an entrance. Couldn't have asked for better timing. So, on the one hand, we have AI that's driving massive, increased compute, massive amounts of GPU investment, massive amounts of not just energy demand, but materials usage. And then on the other hand, we have the climate crisis, which, in New York's quite timely. We literally just had Climate Week, here in New York. So, it's clearly at the top of mind for New York. But my background. So my background is as a technology architect, predominantly started my career in hands-on development, but have been in a range of technology strategy roles and architecture roles, including working in the energy space for many, many years, and working in a little bit in the climate science sort of side of things, working alongside climate scientists, helping them build models and build systems. So I have a bit of knowledge here of this sector, but I'm not an out-and-out climate scientist. And then moved into chief architect roles, run a podcast called Architect Tomorrow, which is all about getting technology strategists and architects to think about how we design better systems in the future. And I lead on sustainable technology at Scott Logic. Scott Logic, for those of you who don't know who we are a B Corp, so that B Corporation is an organisation that's certified as putting more than just profits as important items for our company. And we're predominantly a software and data engineering consultancy. We do a lot of custom software development, particularly for large banks and large government departments. So that's me and Scott Logic. So I talked about some of this reality of technology impact. Can I get a sense in the room of who's seen these UN SDGs before? Okay, a couple of, okay, thank you, Colin. Yeah, a couple of you, cool. So what I did with my team was we did a bit of work. We went, right, let's look at these UN SDGs and look at which ones really technology touches on. And so this slide illustrates those. Now, a lot of time and energy is spent, sorry, pardon the pun, on the energy consumption side of technology. There's a lot of talk about how much energy a data center's using, or is my computer using? Can we just switch that to renewables and we're done? There's a lot of discussion on that. So that's SDG 7 around affordable and clean energy. But the big one that often gets overlooked is what's known as embodied carbon. Is that a term that's familiar to anyone in the room? Show of hands. Yeah, a couple of people nodding. So embodied carbon is essentially not the operation of the device, but it's actually the creation, the shipping, and the disposal of the device. And for some types of device, this actually massively outweighs the use phase. The great example of this is a mobile phone. A cell phone, a mobile, it's typically 80% of its impact is when it's created and disposed of. Only 15, 20% is used in the charging. It makes sense, right? You don't actually use an awful lot of energy in charging a device. But that iPhone or Android phone or whatever it is has a lot of different raw materials in it. A laptop is similar. A laptop is, again, sort of more like sort of 70%, 80% of its manufacturing and the rest in its use. And an insane amount of water is used, insane amount of materials from mining is used to produce a laptop or a smartphone. So these are the sort of hidden impacts. And flipping back to the sort of greenwashing I was talking about earlier, I got particularly angry when I saw Apple's Mother Nature video. I don't know if any of you saw that recently. I found it particularly uncomfortable because their whole business model is driven on selling people a new phone, a new device every year or shorter than that if they can persuade people. And unfortunately, people just don't quite appreciate what goes into producing that device, shipping that device, and ultimately disposing and dealing with that device at the end of its life. But there are a whole bunch of other things here. I won't go into all this. I'm happy to take this offline afterwards. But just to quickly kind of cover them, you've got water usage. Data centers use a massive amount of water, as does the manufacturing of devices, as I just touched on. You've got the impacts of the sort of land usage from data centers, which is growing and growing. But water usage, particularly in water-stressed areas, so there are certain parts of Europe, like Spain, Texas in the US, other parts of the US as well, particularly California, where the water usage for technology is crazy. Just water cooling AI training is something like 1 billion litres of water. It's obscene amounts of water in a world where we're increasingly coming under pressure to kind of conserve and preserve fresh water supplies. It's something we can't just continue to turn a blind eye to. The reason is often because water consumption isn't really a metric that we're evaluating any of the tech companies on. We evaluate them on power usage and carbon, but they get away with water. And actually, by using more water in cooling and things like that, it reduces their energy footprint. So they're able to kind of game the system by using more water, which makes them look more efficient on one metric, but then hide behind the scenes the fact they're actually using an awful lot of water to cool their facilities. And as I said just now, AI is just driving this even further. In the preparation of this talk and the work we're doing with clients, I wanted to kind of touch on some of the challenges that, for some of them, this may well be obvious, why this is so challenging for financial services, right? As I talked about earlier, it could potentially be getting on for 50% of the footprint of a financial services firm is its tech. And that's because finance is predominantly a data-driven business, right? These days it is. It's no longer pushing checks or pieces of paper around. It's bits of information that represent people's account balances or trades. There's a massive amount of volume there, the frequency. The complexity and size of technology estates is a big challenge as well, right? We work with some of our clients who've been, who've got mainframes still. They've got every generation of technology that there has been since computers were used by businesses. So it's this kind of complexity of estates, duplication from getting things to market. It's a blend of having on-premise data centers, multiple cloud deployments, just a whole complex landscape. And the competitive pressure, like at the moment we're seeing this race for AI, we're seeing companies almost forced to kind of compete because one brand is doing it, so another needs to do it because they don't want to be felt like they're left behind. And this race is kind of, the energy consumption curve is pretty scary. Like by 2030, technology is on track to use 20% of energy, or effectively create 20% of energy-related emissions. It's currently about 4%. And flying, global aviation industry, is about 2% of carbon emissions. So today we're at 4%, the technology in whole, not just finance, not just fintech, but it's on track to kind of hit 20% in the next, 5-6 years, which is just scary. Client expectations, kind of needing to deliver world-leading experiences, really fast, trading platforms, really high execution. Drives us to use lots and lots of energy because we throw lots of compute and lots of storage and lots of resources at systems. And then you have regulatory constraints, and this is where it's going to get more challenging because you've had all those things that I've just talked about have been true for many, many years. But now what we're seeing is potentially a bit of tension coming back the other way, with particularly in the EU at the moment, and France is particularly world leading on this. Laws coming into effect that effectively mean if you run a data center, you're now having to report far more on its impact, its energy usage, its emissions, and so on and so forth. So there's going to be, if it's not carbon reporting, there'll be regional and country level obligations to start submitting to, and there'll be this tension increasingly going forward between throwing hardware at a problem versus kind of what does that do to sort of regulatory reporting and fines. So how can open source and open standards help? Well, Vincent, for those of you in the room for Vincent's talk just now, he beautifully illustrated why using open standards is really powerful in the ESG space. But if we think about this, what I'm talking about here is a global challenge. Every bank globally wants to be more efficient, wants to be more responsible, or at least I hope it does. And it's a global challenge, right? So we can work together with the commons, we can create a shared global knowledge for common good. So that's why open source is really, really powerful for me. It allows for community review and validation. One of the things I called out a bunch of the tech firms for just now is greenwashing. One way you can avoid greenwashing is by having science-based, open, transparent standards that you're working with. And then that way, if people challenge you, you can go, well, look, you can go and look at how this has been calculated, how this has been worked out, and how you're kind of working with peers. And scientists can peer review it, auditors can come along and see it very plainly. It doesn't require lots of investigation to see how you come up with numbers. So essentially, kind of to keep it, science-based, to keep it transparent. So some of the things in our research that we've come across, there's some really interesting organisations, and I'll start with the one top right, which is the Green Software Foundation. Interestingly, they're also part of Linux Foundation, so they're a sister organisation to Finos. They do some fantastic resources, some great materials, all of it's open source. There's in particular, there's a training course that I've got a lot of my team back in the UK to do, and it's essentially kind of half day, and it gives you the fundamentals of sustainability in tech. It's a really, really good course. But there are a whole bunch of other groups out there, like the CNCF have a cloud native sustainability group as well. The CNCF, there are quite a few people there here today. SDA is the Sustainable Digital Infrastructure Association, or sorry, the A may be wrong, and that's quite a European-focused organisation looking at building more sustainable digital infrastructure. And then I've put some UK-based organisations on here, but there will be the equivalent, in different regions as well. We have the British Computer Society in the UK looking at this. We have the UK government also looking at this, and Scott Logic is proudly a part of the Government Digital Sustainability Alliance, looking at how, as suppliers to government, do we make things better? How do we make things better? The new one I've just found recently is sustainableIT.org. Highly recommend people look at this. If it's not just looking at environmental sustainability, it's looking at ESG. So it's looking at all the things that IT departments need to think about when it comes to sustainability across the piece. The thing about this, though, is when we looked at this and we did our research, we discovered it's incredibly fragmented and somewhat confusing. Where do you start? There's so many different projects, great organizations doing amazing things, but how do you kind of navigate that and how do you connect all that up? So I'll come on to a piece of work we've done in a moment to kind of simplify this picture. Coming back to the Green Software Foundation for a moment, they have these principles, and some of the key ones of them are energy efficiency, so consuming the least amount of energy possible, hardware efficiency, so kind of trying to minimize the amount of infrastructure you need, whether that's cloud or whether that's on-prem or end-user computing. And then this concept of carbon awareness, which is really interesting. Again, show of hands, who's heard of the term carbon awareness? Okay, all right. So it's effectively a concept that says, try and run your compute workloads when energy is cleaner, so when the grid is less carbon intensive. So if you can run, say for example, your AI machine learning training in a location, perhaps in Scandinavia or Iceland or somewhere where there's clean energy, and you can do your training there, because it's not location specific or dependent, you can move some of your workloads. Either move them physically to places where there's cleaner energy, or move them in time to when your data center is running on cleaner energy. So the batch processing may have a bit of a renaissance, right? If you can run some of the processes at times when there's less demand for energy, you can potentially run your workloads cleaner. So this is this concept of carbon awareness. The tech industry, in going back to my early points, in true greenwashing fashion, is trying to use this a little bit bluntly. Unfortunately, there are some nuances here to looking at a number that says the grid today is this much CO2 per kilowatt hour, which is generally how the carbon intensity is measured. It's often reported on too big a scale, so it's reported on in Europe at a country by country level, or in the US it will be a state by state level. The problem is your data center or your cloud provider is unlikely to actually be drawing power at that carbon intensity. It may well actually have its own solar. It may well be in a place that's sat right next to a coal-fired or gas-fired power station. So it's a lovely idea in principle, and we're kind of keeping an eye on it in our research. I would say be careful with this one, because potentially it's a bit greenwashy, depending on how accurate the data is that you're choosing to change your behaviors where you run your compute or how you run your compute. One of the other interesting things we discovered from our research was there are actually some really nice alignments between sustainability and security, which was quite surprising for us. Not saying it always goes hand in hand, but what we found was trying to create systems that are more energy efficient, more elegant, more simple, actually means that they're often more secure, because a simpler solution often has less attack surface, it's easier to secure. Examples of this move include, in the kind of web world, moving away from content management systems if you don't need them, moving to sort of distributing HTML, going back to sort of HTML, rather than using a content management system if you don't need one, because that's massively simpler than having a whole stack of database and other applications versus a flat file being served off of a server, off of a CDN, a cache essentially. Next one's hardware efficiency. It kind of makes sense, like the less complex your software is and the more straightforward your estate is, the less hardware you need, the less physical hardware attack surface you have. So I used to work for a cybersecurity software solution called Tanium, and one of the things we would advise clients was shut down and remove the things you don't need. So this is a big thing for me, is like so much zombie equipment is out there. There's so much kit, so much equipment that was spun up for a project and is never torn down, or was a POC and is just left to run and run. I come across clients who find stuff in the cupboards, or even some examples extreme, I know, drywalled into walls that people don't even know are there until they do the IT asset analysis. But essentially this one talks about, if you make your hardware more efficient and you use less of it, again you have less of an attack surface, so a nice sort of security alignment there. The one on carbon awareness is interesting as well, because if you build systems that can be moved in time and space and are more flexible, more elastic in their nature, that potentially promotes adaptability, more resilient kind of architectures and better availability, depending on how you kind of go about doing that. Now, I'm not a big fan of really complicated formulas, so sorry for this one, but this is another really important piece of work that the Green Software Foundation have done. It underpins a lot of what goes on out there. So it's this concept of SCI, which is the software carbon intensity measure. It's the metric you can use in the software engineering world to actually measure how much carbon your software is emitting. And it's essentially broken down into these component parts. It talks about the energy that's being used in operating, the running of your software, the running of your servers. It talks about I, which is the carbon intensity. I talked about this just now. You're trying to run on cleaner energy. So if you can run that on cleaner energy, that number will be lower. The M is the embodied carbon, the carbon that was emitted during the manufacturing or the production of the machines that the software is running on. And then what's interesting is R. So the R part of this equation is for doing what? So is it per user? Is it per transaction? Is it, what is it? So the challenge with just calculating software carbon is you can actually look worse if your system gets more popular. So if your business does better, if part of your organization, your kind of trading desk, whatever, does better and it uses more compute and needs more technology to put behind it, it looks dirtier. But if you use R, you can actually divide that by the kind of unit or the kind of, maybe the number of traders or the number of transactions that are flowing through the system. And that's quite crucial because you can show how efficient, how over time, as you perhaps have more trades going through a system or more load going through a system, you can show if the software is getting more efficient or it's getting worse or staying about the same. And this is quite a crucial formula. So I appreciate it's a bit down the weeds, but it's quite a fundamental thing that we've been building a lot of our work on. Now, I talked about a piece of work that we did to try and make this simpler. So we spent a number of months looking at all the work out there, trying to go, right, how do we make this more straightforward? So if we have a sustainability professional in the room, an IT professional in the room, and we want to talk about sustainability of tech, how do we make this simpler? So we started with these three kind of main swim lanes, these three kind of core concepts. Upstream emissions, I talked about earlier, it's largely things like the hardware, in some cases the software, the devices, the infrastructure that you purchase and consume. Those things have emissions when they're being manufactured or being disposed of or being shipped to you. So that's that left-hand column. The operational emissions piece comes in two flavors. We have direct, which is devices and infrastructure that you run as a financial services organization directly. So that's employee laptops or desktops. That's the networking kit and other infrastructure you've got. It's your own servers, your own storage. And if you use backup power generation, it's generators as well, because they use fuel, which obviously creates emissions when it's being run. The second type is indirect. So this is where someone is operating the services on your behalf. So typically cloud services or managed services. So those are often trickier. And as Vincent mentioned earlier, it's often hard to know if the numbers that are being given to you by suppliers are truly accurate or comparable with your own emissions or comparable with another managed service provider or cloud provider. So this is where there's a challenge there. We needed to break this down into these different buckets. And then the downstream one's quite interesting. So downstream is often completely overlooked. So if you build software that's used by another team or a client or a consumer group, it's essentially how efficient is your code, and therefore does that mean that someone has to upgrade their device or upgrade their operating system, whatever, to keep up to date to run your system? Or is it essentially using more energy to run your software? So this is the downstream emission category, which again is often, like I say, in the tech industry, is just not really talked about. Some interesting examples of this include if you build a retail banking app and it's particularly badly written, potentially that's then going to be chewing up people's phone batteries or consuming more cycles on computers. And obviously on an individual user or an individual phone, that doesn't mean anything. But when you have millions of customers, that's significant. And so this downstream piece is the sort of final part of the puzzle. Now, what we've done with our clients is get them to sort of reset with this picture, because many of them, when we start working with them, think it's all about the middle column, all about the operational emissions, all about the electricity they're using and what the carbon is associated with that electricity. What we then do is do a quick kind of assessment of their estate, and we often find it's actually the left-hand column that's as big or bigger than the operational column, and in some cases, particularly for retail banks or retail organizations, it's the downstream emissions that can be significant as well. So if you're very much B2B and you've got a large employee base, it may well be that upstream emissions that most people don't even know about. Show of hands earlier was a couple of hands, right, who knew about embodied carbon. In fact, that's where the majority of the emissions of tech are for a lot of organizations. And that's why the numbers look far, far bigger than people are being led to believe. For others, yes, it will be the compute. If you've got lots of AI going on, you've got lots of high-performance compute, lots of Monte Carlo sims or lots of modeling going on, then yes, the data centers that you have or your cloud provider has, running them, the carbon footprint of those will be significant. But what we wanted to do with this was start with the basics. So what is actually going on? What's relevant to your organization? And then just finally, for those of you that know the GHG protocol, the GHG protocol has 3 scopes. And this is the piece where the sustainability professional in the room can see at a glance, where does the technology estate fit into scope 1, scope 2, or scope 3? Now, there's not much scope 1 in the tech estate unless you're running things like generators, backup generators for your data centers. There's a lot of scope 2, the electricity that's consumed by your devices. Scope 3 is massive. So scope 3, for those who don't know, is essentially your supply chain emissions. It's really, really difficult and complicated. People don't agree how to measure it. And so this is where we do a lot of work with our clients on, right, how do you more accurately measure and benchmark this against your peers such that you've got something that you can stand behind scientifically when you're challenged on this or when you're about to start submitting regulatory reporting? And also, how can you influence your suppliers to be more transparent, give you the data that you need in order to understand whether moving to cloud is actually more sustainable? Because at the moment, you'll just get the marketing message rather than the real data and the reality. One thing I'm excited that Teams launched recently is this estimator tool. So this is open source, as is, sorry, I should have said, the picture I just showed you just now is actually the homepage of the website. You can drill down and click through, see the different descriptions. That's all open source. And then the estimator tool is essentially what we've done to try and bring this to life. So I said earlier, for some organizations, the different parts of the picture are bigger and smaller. This essentially resizes based on what you put in. And it's a very simple, quick form. It's one page. It's not intended to be scientifically robust. It's just intended to kind of give you an idea of where the emissions are probably going to be in your tech landscape. So I'm pretty much done. I'll just kind of quickly recap. I see this as a massive opportunity, to be honest. One thing I didn't really get time to talk about was how some organizations now are using their data centers as a source of heat and then selling that heat to swimming pools, to communities that need heat, like condos, apartment buildings. Really smart organizations are seeing the waste products of their technology as actually value elsewhere. So there's a really interesting company in the UK called Deep Green looking at doing this. So where are the places you can flip this into an opportunity as much of a risk? Educating stakeholders is key. Like, as I suspected, not many of you in the room perhaps particularly aware of a lot of the impact of technology. Hence why I'm kind of doing a lot of talks on this topic. We've got to get people to understand what the impacts of their tech are. Unfortunately, that's just not really well understood. I believe sustainability needs to be on the same level of footing as something like security. It needs to be given the same prioritization. And I think it will be ultimately as energy probably becomes more and more expensive, and there are more and more fines and incentives to reduce carbon and reduce emissions. I think we will probably see financial levers will help sustainability go up that list of priorities, but I think it needs to be up there. Open standards, real big fan of that. That's how we've been able to do a lot of our work with our clients, is building on the open standards, the open source projects that are out there. There's some great ones. We're aiming to use the Tech Carbon Standard to help people navigate and find them, the ones that are out there, so you can make advantage of them. And then the last point really is just to be conscientious of unintended consequences. So when you say this to technology teams that are building platforms, this thing needs 5 nines availability, or it's a gold standard application. Is it really? Because if you do stipulate those sort of really high performance constraints, it starts to put in more redundancy, it starts to mean there's duplication, there's more energy consumed. I think we need to be really conscientious from the start of our projects when we're kicking things off. What truly are the requirements, and are we prepared to make trade-offs to bring sustainability considerations in against some of those things? Because I think often it's the easiest option is just to go, yeah, make it max, make it gold, put it on millions of servers, make sure it's in every cloud environment possible. But is that really necessary? So that's the sort of, I suppose, final point I would leave you with is that let's try and think a bit more conscientiously about how we build technology. And with that, I think I'm done. Any questions? I should just say that the website techcarbonstandard.org is where you can find the work we've been doing. So yeah, if you want to find out more, that's there. Yeah. So I have to full disclosure. The work we're doing with financial services clients is quite early in maturity. So it's much more about raising awareness and helping them understand their future projects to optimize. With more other clients that are on the retail space that have got more targets or have more of a consumer pressure to do this, we have helped them identify savings. Like our own example is we found 20% of cost savings, I think 26% of carbon savings by doing this, because we discovered things that we were doing that were suboptimal. But yeah, typically, I think most clients that we work with have something like 15 to 20% of IT assets that they're not actually using. That's an immediate cost saving and an immediate sustainability improvement. And our whole mission isn't just to help people report on this; it's actually to help people take action and improve and mitigate. But it's a journey. To start with, you just need to work on the right thing, because a lot of people think it's solved. They've moved it to the cloud. They're done. No, raise awareness and get people then to work out where is it in their estate that they need to prioritize. And then, what can we do to mitigate that and improve the picture? Yeah, you're right. That can potentially outweigh the technology emissions massively, right? I think a lot of them come to us because they want to practice what they're preaching. If they're saying to clients, we want you to decarbonize because we'll give you a better interest rate or a better product, they need to be kind of say that the way they're running their estate is also sustainable or trending in that direction. So that's been a lot of it, is either been wanting to sort of practice what they preach, or it's been communities of practice within financial services firms that are almost side of desk, care about this passionately on an individual basis, but then come to us and say, Oliver, how can we make this a real thing, a real finance program that shows return on investment? Because there often is massive return on investment for doing these sorts of programs. So yeah, it tends to come from one of those two directions in the financial services world. In the non-financial services world, I touched on it just now, it tends to be either consumer brand pressure, regulatory sort of pressures. But yeah, so I think there's at least 4 or 5 drivers now that are bringing people to the table to ask for help on this topic. So software running on hardware is 2% of global, is 4% of, nearly 4% of global emissions today. Yeah. To put it into context, flying is 2%. So software running on something, because obviously software not running doesn't have an awful lot of impact. But when it's running on the the world's data centers or in cloud environments, is now approaching 4% of carbon emissions per year. So it's significant. And it's, like I say, it's on track to get much, much bigger. It can be, but you can architect in a smart way, right? You can build those sort of failover systems to run on demand or scale up, scale down. I think I see an awful lot, to get a little bit preachy, but I see a lot of lazy architecture in that we'll just run standby site on high, fully running, whether it needs to be or not. Whereas it is possible, because I've done this work on many projects, to look at scaling, particularly in cloud. Use that elastic scalability to go, we'll have a minimal, enough infrastructure running in the alternative cloud provider or the alternative data center, which then ramps up when the demand hits it, rather than having it running all the time. The other thing is probably overlooked is non-production environments as well, right? Like the amount of stuff that's running 24/7 when actually developers and testers are only using those platforms during the working day. It's some of those kind of more smarter choices around how we're running things and where we're provisioning things that can save an awful lot. Yes and no. They give you their own proprietary data, which is incomparable. So if you take AWS's, it's not comparable with Google's or Microsoft's, which is frustrating. And it's hard to know how they've come up with those numbers. And they've often used things like I talked about at the beginning. They use a carbon accountancy trick called market-based kind of carbon rather than location-based. So they can effectively claim things look greener than they really are by essentially using clever kind of carbon schemes or reporting mechanisms.
Just one note, I'm at Google Cloud, and we actually do have location-based as well. Happy to follow up on that.
So the slide at the beginning, you probably couldn't see it, but there was one about the different cloud providers. And yeah, if you click into the report, Google is much closer to its actual emissions than others who are thousands times out of what their real emissions are. Anyway, I could go on about this all day, and I suspect there's probably another speaker lined up to talk in here. So happy to take this offline, and really keen to talk to you about this topic. Spread the word. Thanks.